All right, so now we're going to go ahead and use the square root property to solve equations. Okay. So the square root property, all it means is that if we're going to cancel out the square, we need to do the opposite of squaring. Now, if you remember, when we square something like 3, that's the same thing as saying 3 times 3, which is equal to 9. Okay. But what if we wanted to go back to 3? So 9, again, is equal to 3 to the power of 2. We know that. So if we take the square root, that cancels out the square and we're left with 3. So we're going to do something very similar when we're solving equations. So for example, this first one right here. If we take the square root of both sides here, then x is equal to the square root of 32. And we want to simplify it as much as we can. In this case, this could be square root of 16. The factors are square root of 16 and square root of 2. And the square root of 16, which is a perfect square, is 4. And then we can just leave square root of 2 by itself. And the answer is 4 square root of 2. So let's go on to the next one. Now the next one takes a little bit of algebra. We want to leave x squared by itself. So we're going to add 50 on both sides. And that cancels out. So we have 50 is equal to 5x squared. Then we're going to divide both sides by 5. That cancels out. So x squared is 50 divided by 5, which is 10. We're going to go ahead and take the square root of both sides. So x is equal to the square root of 10. Now we want to try and simplify this if we can. But in this case we can't, because the factors of 10 are 1 and 10, 2 and 5. And none of those are perfect squares. So if we can't simplify it, we're just going to leave it like that. X square root of 10. All right, on to this next one. So when we take the square root right here, this is gonna be the first thing that we do because the square root is covering everything. So we need to first cancel that out. We're gonna have x plus 3 is equal to the square root of 20. Now square root of 20 can be written as 4 times 5, where 4 is a perfect square. So square root of 4 is 2 square roots of 5. Now we want to leave x by itself. And to do that, we're subtracting 3 on both sides. So x is equal to, and we're just going to write it down as 2 square root of 5 minus 3. We're not actually doing any of the operations and really combine those two, so that's how we're going to write it down. Now this last one does combine a couple other things. So first off, we want to leave the square by itself, so we're going to subtract 2. That's going to give us negative 9. And we have 5x minus 2 squared. So if we take the square root of both sides, we're going to have 5x minus 2. And then the square root of negative 9 is actually equal to 3i. Now if we take the square root of a negative number, it becomes imaginary. So then we're going to add 2 on both sides. That's 5x is equal to 3i plus 2. And then we're going to divide by 5. So x is equal to 3i plus 2, and all that divided by 5.